Assalamu alaikum warahmatullah. Hi everyone. Let's continue doing the fourth file, which is question 4. We are at question 11. We have a region shaded in the graph above. It's bounded by a horizontal line, a vertical line, and a function. The region R is the base of a solid. So this is what it says. The region R is the base of a solid. The cross sections are perpendicular to the x-axis. The cross sections are squares. Find the volume of the solid. Well, to find the volume of this solid, you will integrate from 0 all the way to 2, from 0 to 2, right? So you are integrating from 0 to 2. Now the cross section looks something like this, which is the difference between the upper one, which is 6 minus the lower one, which is 4 ln of 3 minus x. This is squared because this is squares dx. This is equal to 266. Okay. Now question 12. Let R be the region in the first quadrant bounded by the graph of y equals root of x. Okay, so this is the graph of y equals root of x, and this is the graph of, this is here, it's passing through the origin. The green one is y equals 1 over 3x. X over 3 is the same as 1 over 3x. So we need to find what the volume of the solid with cross sections perpendicular to the y-axis and the cross sections are squares. So we must first find the intersection points between the two functions. The intersection points between the two functions, this one is going to be by the graphing calculator, or by setting the two functions equal to each other. It will be 9, 3. Okay, and this area that we are interested in, so we need to isolate x here. So x will be y squared and x will equal to 3y, right? So the volume is given by the integral from 0 to 3, okay? From 0 to 3, because we are interested in y values of upper, which is y squared. No, not the upper here, we say outer, sorry, which is the green line. Okay, which is going to be 3y minus the closer one to the y-axis, which is y squared, but this is all squared dy. Now the volume will be the integral from 0 to 3 of, let's expand this one, it will be 9y squared minus 6y cubed plus y to the power of 4 dy. Now this one is 9 over 3y to the power of 3 minus 6y to the power of 4 over 4 plus y to the power of 5 over 5. Evaluated from what? Evaluated from 0 to 3. This is going to be 81 over 10 or 8.1. This is question 12. Moving on to question 13. Let me just get some space. Okay, question 13, we have a function f and another function g. They are defined by the given function in the question. Let R and S be the two regions enclosed by the two graphs. Find the sum of the areas of region R and region S. Well, we know that this starts at 0, okay, it ends at x equals 2, but we don't know the intersection points between them. So we must set the two functions equal to each other. So if you set f of x equals to g of x, or if you graph them in your graphing calculator, you will get the intersection points. Let's name it A and B. The intersection points is 1.03, 2832, comma, the y coordinate is 2.401108. So this is the intersection point between the two functions. Now, find the sum of the areas. Okay, so let's start with part A now. Part A, to find the area, you will go from 0 all the way to A. Okay, let's name this one here A. Of the upper function, well, the upper function is g of x, and this one is f of x. Sorry, no, this is the same. I mean, this is f, and this is g, and this is f. Okay, how did I know? I graphed them in the graphing calculator. Okay, so here I have g, which is the upper, minus f, g of x, minus f of x. G of x minus f of x dx plus, now the second one, we are going from A all the way to 2, right? Now the upper function becomes f. Look, this is now f, and the lower function is g. So f of x minus g of x dx. So for the sake of time, I'm not going to write what g and f are. They are in the question. The final answer is going to be 2.004, right? 2.004. This is part A. Well, part B says region S, which is the second one to the right. It represents the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. Okay, the volume of the solid will be given by the integral from A to 2, because we are interested in the second region, S, right? The upper one is going to be F minus G all squared dx. Why squared? Because it says the cross sections are squares. So evaluate this one, you must get 1.283. This is the answer of the second part. Well, let me just drag the next question down. Okay, let's carry on here. Let H be the vertical distance between the graphs of F and G in region S. Find the rate at which H changes when, with respect to X when X equals 1.8. So, H of X, let me write f of X. H of X, if you look at the graph, sorry. If you look at the graph, h of x, it represents the vertical distance between the two functions in region S, which is going to be f of x minus g of x, right? We need to find h prime, the rate of change of h with respect to x at x equals 1.8. Well, we can use our calculator, whatever calculator we can use, of f of x minus g of x. Of course, in your calculator, you are writing what f is and what g is. They are here, f and g. I'm not writing them because they are too long. This is at x equals 1.8. You are getting what? This is question 13 minus 3.8117. That is question 13. Well, let's move to question 14. Question 14, we have a region in the first quadrant under the graph of y equals 1 over root of x. Well, if you use the graphic calculator to sketch the area, it's something that looks, it looks something like this. It goes from 4 to 9. So this is the part we are interested in. This is a rough estimate of the area. Okay, you can get an accurate graph by the calculator. Okay, but this is for the purpose of this question. This is enough, right? Find the area R. Well, the area R for part A, the area is given by the integral from 4 to 9. The area under the curve. What's the curve? 1 over root of x dx, right? This is equal to 2. Okay, part B. If line X divides the region R into 2 regions of equal area, what is the value of K? Since there is a vertical line, X equals K, it didn't say vertical, but I know that X equals K, X equals a number is a vertical line. So somewhere there is what? A vertical line, K, X equals K. It divides the area into 2 equals parts. So that to find what K is, you can find the area of the first half of the region. It goes from the 4 to K of the function 1 over root of x dx, which is equal to what? It's equal to half of the total area, which we just found. So half of 2, which is 1. Okay, solve for what? For K in your calculator. This is going to give you what? Is it a calculator actually question? Well, let's do it manually. It doesn't hurt, right? So to do it manually, you've got to say what? The integral from 4 to K. This is x to the power of negative half dx equals half times 2 is 1. Now integrate. This is x, add 1, it will be 1 over 2. Divide by 1 over 2 or multiply by 2 over 1. And this is evaluated from 4 to K. And this is equal to 1. Okay? Now, this is 2 root of x evaluated from 4 to K, right, equals 1. Now plug in the upper minus lower. 2 root of K minus 2 root of 4 equals 1. Solve this one, you get K equals ln of 9 over 4. ln of 9 over 4. No, this is parts. No, this is the answer of part C, sorry. K will be 25 over 4. 25 over 4. Now going back to part C, says find the volume of the solid whose base is a region R and whose cross sections cut by planes perpendicular to the x-axis and squares. Well, this is very simple. Part C, the volume is given by the integral from 4 to 9 of 1 over root of x all squared dx. Okay, this is the integral from 4 to 9 of 1 over x dx, right? What's the integral of 1 over x? It is ln of x, evaluated from 4 to 9. It is ln of 9 minus ln of 4, which is ln of 9 over 4. This is the last answer. This is part C. I hope I was not explaining too fast, and I hope everything is clear. That's it for question 14. Good luck.